Welcome back. So before we begin, like few quick announcements. One, based on the discussions before we started the lecture, is about assignment 3. So A3 should be simpler and easier. So I made it purposely simpler, than the other two assignments, so that you can spend your time on the Kaggle competition and preparing for the exams and so on. So you can use whatever you want as an in general sklearn, right? Which has algorithms implemented, but the pre-processing steps has to be done by you. So you cannot use things like Spacy or NLTK. So constructing the vocabulary is something that you should do by yourself. So that is part of the exercise. Yes. Now, this instruction is already there in the assignment itself. So I will not accept any emails later saying, oh, I did not know that I should not use this package for pre-processing, and I did my pre-processing using a package, okay? So all the pre-processing to construct the feature vectors has to be implemented by you, okay? You cannot use packages to do that. However, for algorithms, like decision trees, which you're going to see today, and I'm not sure what are the other algorithms asked for, like naive Bayes and logistic regression maybe. So these things you can use sklearn, and if you had you attended the sklearn tutorial, then you pretty much have the code in the Colab. All you have to do is construct your features and put together things. So it should be fairly straightforward. Having said that, the learning goal for the third assignment is really hyperparameter tuning, okay? Because you have algorithms given to you. So one of the most important practical skills that you should develop is how to tune these algorithms better. So make use of the third assignment to explore more about hyperparameter tuning. Okay, so don't do it in a blind way. Okay, so don't take 500 possible configurations and just run them overnight and get the best result. Try to do it in a more systematic way. Think about what are the best ways in which you could do hyperparameter tuning. I'm leaving it to you, but there are a lot of articles online on explaining you how to do these things. So it's part of your learning for the assignment. Okay. Any questions? Yeah, you had a question?
Are we allowed to use pandas?
Use what?
Pandas for this, if you want to put the pandas.
I don't know what are all the options in pandas. If you're just storing your vectors in pandas, it's okay. But if you're constructing the vocabulary using pandas, no. So pre-processing and vocabulary construction has to be done by you. Okay. After that, once you have the feature vectors and once you have the data set prepared, then you can use pandas for the data set or whatever you want. And the assignment asks you to use sklearn for algorithms, so you can't change that. Yeah.
So what you mean it has to be done by ourselves? We can even use the structures that exist already in Python,
basic Python functions are fine. String functions are fine.
Because, for example, the value can be done in one line with a counter dictionary.
Yeah, well, anything that you can do with basic Python operations is okay.
I tried this question.
Sorry?
Someone asked if we can use regular expression. It's okay to use.
It's okay. But you don't need to go that complicated. We are asking you to do only two pre-processing, right? Removing, lowercasing and removing special characters or something like that. Yeah, so it's easier. Well, yeah, you could use regex. Yeah. Okay, so that's about the assignment 3. So A2 will be released anytime soon. So hopefully we're aiming for today, but maybe in the next couple of days. Okay, so now depending on the feedback from both the courses, I don't know which course feedback was this. So we have some modifications to the regrading policy. Okay, so last assignment, students felt 3 days was too short. So we are going to make it 5 days for regrading request. And I have also asked the TAs to regrade your requests as soon as possible, so that you have a chance to ask for a regrade if you want within this 5 prayer window. Okay, so this is because some students thought they need more back and forth with the TAs. Okay, so we're trying to make it more efficient this time. Like so, 5 days, and TAs will evaluate as soon as possible. Well, within their limited availability, so maybe within a day or so. Okay. However, please use these requests more sparsely. Okay, so when you ask for a request, be considerate, explain things clearly, and don't ask for 100 regrades on an assignment. Okay, so like so try to be more considerate. Like so, think twice before asking for a regrade. Okay, and also I will send out the policy when I'm releasing the assignment. But let us say that you should ask your regrade in 4 days, not 5 days. Okay, so give the 5th day for the TAs to evaluate and give you one last chance to hear back. Like so, for example, like if you make your regrade request like just 2 hours before the deadline, you cannot expect them to regrade it and give you another chance to ask for more clarifications. Okay, 5 days window period, but 4 days for asking requests. So 5th day is only for second request or third request if you want to talk more. Is that clear? And other than that, so we should also open the Kaggle competition. Like the competition starts on November 8th, but we should open the challenge in a couple of days. Okay, so this gives you room for signing up. Okay, so we won't provide you the data. It is just signing up period, like so until November 8th. So you will sign up, I think, as individuals first, and then you form teams. But the point is, by November 8th, you should have registered your teams. You cannot be individual in the leaderboard. Okay, so we will remove all the individual accounts and close the registration on November 8th. So when we start the competition, like we should have all the teams in. So make sure you do that. And one last thing about assignment. Okay, so for the first assignment, I accepted some students' request saying, oh, I submitted my report in Moodle instead of Gradescope, or I submitted both of them together zipped, and so on. Okay, we will not do that for the second assignment or third assignment. Like so, that is the whole purpose of instructions, right? Like so, instructions clearly tell you submit your report in PDF, submit your like code in the Moodle channel. Okay, and there were also some cases where people had a report in Gradescope, but when we go see the code, there was no code. Okay, so maybe students thought that we will never open the code. Like TAs, we have TAs distributing the load, so there is somebody checking your code, and like if we just have the final numbers on accuracy, but there is no code which produce these accuracy, you get a 0. You don't get marks for that accuracy. Okay, so who knows how those accuracy numbers were generated, right? Like so, there should be code supporting your report. These are not common issues. It's one out of 100, but I'm saying that now so that you can be more careful for the future assignment. Yeah.
For the Kaggle competition, is it, for example, it's on 35% for the course? Is the person with the highest mark that is 35%?
No.
Or is like
no.
usual exam, like 2020 is like 20 on 20 is the equivalent of 35%?
No. We will when we open the challenge, we will also give you all the details. Like, but your scores are not just based on the ranking. So your scores are based on part of your part of your grade is based on the ranking in the leaderboard, but significant part of your marks are also based on the report that you're writing. So it's not just get the first rank and you get 35 out of 35. Okay, so I think that's a lot of announcements, so we can get started. Are there any questions that I missed in chat? No. Okay, let's get started. So I think after a couple of weeks of heavy stuff, like today we are going to do some light things. Okay, so if you remember, like so last week we discussed about, are there any questions? Okay, so last week we discussed about support vector missions, right? So today we are going to see a totally new class of algorithms, okay? So which is the idea of decision trees. Okay. Now, what are decision trees, right? Like, so now you will see that this is fundamentally like very different from like the mathematical models that we have seen so far. Like so far, the general recipe was you take the data, like whatever the format of the data, you convert it into numbers, like a vector, right? So then you feed this vector into some model. Like it could be a simple linear regression model, or it could be a logistic regression, or like what else, like so SVM or GDA, whatever, right? Like so you had a vector as an input, and you pass this vector and try to make some predictions, right? Now, the models that we saw so far are something like WX plus V, always, right? Like it's an equation which you can implement, and once you implement it, like given any question, you can just make the prediction easily, right? Like so. Now we are going to see a new class of models, okay? So which is this idea of decision trees, like which is going to differ from the previous algorithms in two main ways. Okay, so first of all, so here is an example. So first of all, decision trees can actually take any form of input. Okay, so it need not be just numbers. Like so, for example, in this case, like I have this data set which is going to be a running example today. Like so here, this is basically like deciding whether to give loan to someone or not. Okay, now a lot of banks have this system. Like whether it is a smart algorithm or not so smart algorithm is a different question, right? Like so, but in general, they use some machine learning to decide whether to give loan to you or not. Okay. Now, in this case, given a file, the bank teller is interested in deciding whether this person like has defaulted, like or would default, in which case I will not give loan to him. Okay. So you can see that there are a few features here, like so, like whether this person has a home or not, like homeowners, or like what is the marital status of this person, like that we are testing, right? Like, and what is the annual income? Okay, there's going to be hundreds of features, but for example, we have these three features. Now, given these three features, I want to decide whether to give like loan to somebody or not. Okay. Now, if you want to do logistic regression for this binary classification problem, like so, the first thing that you have to do is take this and convert it into some binary feature, right? Like 0 or 1, and you will take this. This has three possible options: single, married, and divorced, right? Like so, then maybe you can construct three different features, each 0 or 1 for single or married or divorced, right? Like so, you will construct this feature vector, and then you will pass it to the logistic regression, right? Like on the other hand, with decision trees, like you can just pass these things as such, and decision trees can handle categorical attributes or nominal attributes or like ordinal attributes, like so whatever kind of attributes or features you want to give it. Okay. Now, the second major difference is instead of having the simple equation which implements the model, we're going to have a tree which is like representing the model. Okay. So in this case, given this data set, the learning component of decision tree is to construct this tree. Okay. Now, once you construct the tree, then you can use this tree to make new predictions. Okay. So now let us see an example. Okay. So now let's say here is a new test data. Okay. And I want to decide whether this person will cheat by like defaulting loan. I'm just considering that as cheating, like whether this person will cheat or not. Okay. So now the way in which we are going to work on this is like we'll start with the root of the tree. Okay. So the root of the tree is checking whether the person is homeowner or not. If the person is a homeowner, then you go to the left, and it says that no, he will not cheat. Okay. Now, if the person is not a homeowner, which is the case now, so then you move to the next level of testing. Okay. So now you are checking the marital status of the person. Okay. In this case, it is married. So if somebody is married, then this tree says that they will not cheat in paying back. So you can trust this person. Okay. Like, so for this particular test data, so the answer is no. Is that clear? Like similarly, like if the person is single or divorced, then you go check the income. If you think that the income is less than 80K, they will not cheat. This is a weird rule. It says if the income is more, they might cheat. Okay, so, but this is not a true decision tree. This is just an example. Is it clear? Any questions on how to, well, we haven't seen how to construct this tree yet, but is it clear how to use this tree, right? Like, so if, given the data set, if I can construct a tree like this, okay, from here to here, okay, so this is the learning part, then prediction is easy. Like, so you just test a bunch of things and you can make prediction, okay? Now, of course, the most interesting question for this course is like, how do I learn this tree, right? Like, so any ideas? Like, so given this data set, how can I, like, what are the possible ways in which I can construct this tree? So how do I decide that I should first check homeowner? Like, or why did I decide that I should first check homeowner? Yeah?
The most important, the most correlation.
Okay, so the most important or most correlated feature with the label, okay, yeah?
So it's either 0 or 1, so for yes or no, so we immediately know if it's gonna descend into something else. Because the divorced, single, or married.
But that is also a binary choice, right?
No, because it's split in two. It's split in kind of two, but like there's married and there's single and divorced.
Okay.
There's another option.
Okay, but that is just a coincidence with this graph. Okay, so yes or no is not the reason why we put it in the top. Yeah.
So random choice.
Okay, random choice. Okay, any other answer? Yeah.
The first variable that allows to split the data along these axes for the most effective way possible.
Okay. Oh, by the way, people in Zoom, you can post your answers. So as I keep saying, you can all post your answers. I'm going to read it. Let me finish that. So like to rephrase you, like, so divide the data, pick a feature which divides the data in a more predictable way. Can I say that? Okay. So you had an answer?
I would say you take the one with the less feature first, and after you increase the feature every step.
What do you mean by less?
From the two yes or no.
Oh, okay. No, I think that was same as that answer.
Yeah, I think.
Okay. So, well, I'm not sure if that is optimal. Like, so deciding based on how many ways to split, I'm not sure that is an optimal way to split. Yeah, you had something?
Take the one that give you a definitive answer first.
Okay, that is similar to his suggestion. Like, so I think if I have to summarize all your suggestions, right? Like, so, like the most common theme is pick something that is most important for the task, like for prediction, right? Like, so pick a feature which is going to give me a good answer. Well, of course, that is our goal, right? Like, so now how do I pick that feature? Like, so some answers were pick features which separates the data into two parts, okay? So that ideally it becomes more predictable. Okay, let us look at this example, right? Like, so now think about homeowner. Okay, so you can see that whenever is it okay, let's try to count. Let's try to count the number of homeowners. Okay, so if homeowners is yes, it's here, 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 the three cases, right? So you can see that in our entire data set, whenever someone is a homeowner, that person does not cheat, right? So it is almost 100% guarantee that like you go here, like the problem is solved, right? So this kind of makes a good split. So now you have this mixed bag here, which comes to the other side, right? Again, you do this recursively, like find a feature which is going to give you this maximum possible split, like which has better way of predicting. Yeah.
Does each step need to be one feature, or it can be like a little model or something?
It is one feature, like you are doing it recursively.
For example, instead of income, could not have like income and the risk of the event if you want.
Oh, you mean can I consider compound features?
Yeah.
You can consider compound features, but it is just that as we will see how we are going to construct these trees, the moment you start considering compound features, it's going to be combinatorially many possibilities and just maybe not worth it. Okay, so we will think about it towards the end. But for now, here is the general recipe. Okay, so the general recipe is also known as Hunt's algorithm. Okay, so this is a recursive procedure. Okay, so we are going to repeat this algorithm recursively. Okay, so in the first in the root of the node. Okay, now you make a choice, then you go to the next level, you make a choice, and you go to the next level and you make a choice, right? Like, so initially you start with this big data set. Let's call it D. Okay, now every time I make a choice, I'm essentially dividing this data set into two components, right? So every time I make a choice, let's say it's an yes or no choice, then I take the data set. Let's say this is the feature I care about. Whenever there is an yes, right, I put that data set here. Let's call it D1, and I put the remaining data set here, right? So once you divide the data set, now you can see that this problem can be formulated in a recursive way. So now the question becomes, what is the best possible tree starting here, right? That requires you to divide the data set again, and then like what is the best possible tree starting there, right? So we are going to do this greedy recursive approach, in the sense that every time, every layer, we are going to be greedy and say, okay, what is the best possible thing to do here? Then I repeat it. Is that clear? Now, when do I stop? Right? Like, well, there are many questions here. Like, when do I stop? How to split? Like how many ways to split and all those things. We are going to answer all these questions. But I'll first explain the general procedure. The general procedure is, let's say I reach here, any node. Okay. Now, if it contains all the examples from just one class, then we are done, right? Like, so let's say it's a binary classification problem 0, 1. Now this data set has all 1. Then we can stop the recursion here and just say now class value is equal to 1. You stop it. Okay. There is another way in which you could stop, which is when you have an empty data set. Okay. So let us say I do the split yes and no. And it so happens that there is not any examples in the data set which has no as the feature. Okay, no for this feature. Then you have an empty data set. So whenever you stop with an empty data set, okay, so when you have all example from one class, then you will stop with the class label c is equal to 1 or c is equal to 0 otherwise, right? Similarly, when you reach empty data set, then your class label is going to be some default class. You can have a default class, which is, for example, in the case of bank application, right? Banks don't want to take risk. So the default option is to not give loan. Okay, so they can just say that if they're not sure about the case, then they would say no loan. Okay, so you have a default class. Now, the most interesting criteria, like scenario, is the third one, which is you have mixed data set. You have a data set, but it has some yes, some no. Okay. In which case, like, you're going to find the best attribute to split, and you're going to repeat this procedure recursively. Is that clear? So this general idea of recursively splitting the data, right? Like, so this is Hunt's algorithm, like, and this is a meta algorithm in the sense it's a general recipe. There are hundreds of decision tree algorithms out there. Okay, so For the purpose of this lecture, we will not discuss any specific implementation. Like, so for example, there is CART, C4.5, there are Splint, like there are lots of decision tree algorithms, okay? But we are only going to discuss the general recipe for constructing trees. However, like I think when you are using decision trees in sklearn, you can choose which algorithm you want to use. Like, and in fact, that is also a hyperparameter, right? You can try different algorithms. And if you want to learn more about what is the difference between these algorithms, you can go read about them. But today we are going to just see one general recipe for all these algorithms, okay? Now, the most important question to answer, like with this Hunt's algorithm, is like how to split the data. Right? Now, as I mentioned before, like so we're going to take a greedy strategy, okay, which means that we are going to split the records based on some attribute. Okay, by the way, so attributes and features are same, okay, so I use either of them, like map it back. So some attribute test, okay, that optimizes certain criteria. Okay, so we're going to define a mathematical criteria which we think is the definition for best split, okay, and then the problem becomes simpler. You just compute this criteria for different possibilities, pick the best possibility. Is that clear? No. To implement this, there are a bunch of questions that we need to answer, okay. So first of all, how to specify the test conditions, okay. So in the example that I showed, you saw there is a binary example and there is like a marital status which has 3 options, right? Like, so there are many types of attributes. Like, now how do I decide like the tests themselves, right? Like, so like, am I going to test for yes or no, or I'm going to test for 3-way or like 2-way or combined 2-way and so on, right? Like, so how to specify the attribute test conditions. The second question is how to determine the best split. Okay, and the last question is when to stop splitting. So once we have answers for all these 3 questions, then we have a complete algorithm. Like I can implement this algorithm, give the data set, it is going to give me a tree. Okay, now let's answer them one by one. So the first question is how to specify the attribute test condition. Okay, now this depends on what type of attribute we are looking at. Okay, so there are 3 possible attributes. One is nominal. So this is just categorical. Okay, so like things like marital status. There are 3 options, right? So single, married, divorced, right? Like, so now these are examples for nominal attributes. Now the other obvious choice is continuous attributes like annual income. Annual income is a continuous valued attribute. Like it could be from 0 to any high level number that you want, right? Like it's a real value. And there is also a third class, okay, which is in between these 2, like which is the idea of ordinal attributes. Okay, now what do I mean by ordinal attributes? Like, so for example, let's take t-shirt sizes. Okay, you have extra small, small, medium, large, extra large, XXL, and so on, right? So now it is basically a nominal attribute because you have a bunch of categorical options. However, there is an ordering in this attribute, right? Like, so we know that XS is smaller than small, then small is smaller than medium, and so on, right? Like, so there is an ordering, natural ordering. So which means it's an example of ordinal attribute. The other example could be in general, like let's say we have a category which says whether something is low, medium, or high, or something which like age, for example, right? Like it's an ordinal attribute. So ordinal attribute could be either nominal or continuous. but it also has some specific ordinal importance for the values. Okay, so now depending on what kind of attributes you have, like we're going to have multiple options. Now there is also another question, which is like how many ways to split. Like, do we always want to do two-way splits? Do I always want to split into two parts in the tree, or I can do multi-way split? Okay, so for example, let's say I have something like car type. Okay, now I could have 3 different types of cars: family cars, sports, and luxury. Okay, now multi-way split basically means I split into how many ever options available. If there are 3 options available, I have 3 routes from this node. If there are 5 options, 5 routes. Okay, so however, a lot of specific versions of these algorithms would only handle binary splits, which means if you have 3 features, you have to decide some way to combine them so that you have only 2 options. Okay, so for example, let's take the same car example, right? Like, so we're going to do binary split. Okay, now you can take the car type. One possible binary split is whether something is sports, luxury, or family. Okay, now the other possible thing is family, luxury, or sports. Now, what can you say about the quality of these 2 splits? Like, do you have a preference for one over another? Sorry?
You can't really tell.
We can't really tell, like, so, but when can you tell? What more information do you need to tell?
The size of the groups.
Is it just enough? Like, so the quality of the split depends on the data, right? Like, so, and in turn it depends on the task. Depending on what problem you are working on, right? Like, one is better over the another. Like, so for example, let's say you are considering like some prediction problem which involves like speed. Okay, then maybe this is a better split, right? On the other hand, like, let's say something which involves like specifically about family, then probably the first one is better, right? Like, so we cannot say what is better by just looking at this tree. Like, so we need some other criteria to decide what is better. So whenever you have these kind of options, what you will do is you will consider all possible combinations and compute the criteria and pick the one which satisfies the criteria the most. Okay, is that clear? Now, what about this split? Let's say I have a size feature and I divide it into small, large in one side and medium in another side. So can you guess what kind of application would expect you to have this kind of split?
Ordinal.
Hmm?
Ordinal attributes.
Sorry?
Ordinal.
Sorry, I don't hear you.
Ordinal.
No, I mean, like,
Oh.
I'm asking for what kind of applications, like where you will group small and large together and medium separately. Yeah?
So you mentioned, for example, categorize the PCs from machines inventory, and every piece is made with a medium size fits the pattern. And every piece that is made out
Yeah, that's a good example. Yeah, I think you can think of many examples for all these cases. Okay. Now this is about splitting two-way or multi-way. Okay. Now there is also another important question about splitting, which is how do I split continuous valued attributes? Okay. Now, let's take annual income, right? So annual income has a huge range, like it could be from 0 to millions of dollars. Okay. Now, how do I split in a specific place to construct a binary or multi-way split, right? Like, so there are many possibilities here. Like, so the first one is the idea of discretization. Okay, so which is basically you take this continuous value, you discretize into bins. Okay, like, and then like just use these bins, and now you treat this as a discrete feature. Okay, so for example, you can take the income and you could split it into less than 10K, 10K to 25K. It's open. 25K to, let's say, 50K, and let's say 50K to 80K, and greater than 80K. Okay. Now, in this case, this is a 5-way split, and I can take the data set and put examples between this range to these specific bits. Okay. Now, you can decide these bins based on the data, or sometimes this bin is given to you. Like, for example, like there are tax brackets, right? So, like there are various levels of tax brackets. Now, we can just consider those as your feature splitting criteria as well. Okay. Now, this is when you want to do multiple splits. However, like if you think about our example, like I don't want to go back all the way. So if you think about our example, we had this annual income, which was I think split at 80K, I guess. Yeah. So which was split at 80K, right? Like if it is less than 80K, you go in one side. If it is greater than 80K, you go in another side. So now this is actually one single number. So how can I split? How can I find this one number in this long range? Any ideas? So what I want to do is I want to make a binary decision. Okay. So I want to divide the data into something less than V and something greater than or equal to V, let's say. Okay. Now, how can I do that? So what are the possible ways?
We do the average of all the.
Sorry?
So we compute the average of all the incomes and we split it 2 ways. If you're greater than average, you go this way. If you're less than average, you go this way.
Ah, okay. But we don't know if average is the best way to split, right?
What logistic equation?
Sorry?
What logistic equation if you cancel this or not like to work? You can divide these.
Okay, so you do logistic regression and find the midpoint using the. Oh, that's a good idea. Any other ideas? But one thing that we still haven't discussed is the second question. Like, so we haven't discussed what is the criteria for splitting, right? Like, so once you have a criteria, a simple choice to do here is just consider all possible splits, okay, and find the best split. Okay, so now of course it is very difficult here because there are like many possible splits. So just give me one sec. Yeah, but we are going to see an efficient way to do this maybe after the break, okay, or maybe before the break if we go faster. Okay, now I think we discussed a lot about the first question, which is like how to set up the test, two-way or many-way, like ordinal, like and all those things, right? Like so. Now the second question is how to determine the best split. Okay. Now, yeah. Sorry. Sorry, what? Oh, okay. Why is that happening? Okay. Let's see. Okay, it works. Okay, but we have to wait for the screen to resolve. But I wish I can just write in board and there is a smart video recorder which captures and put it in the Zoom. Okay, let's just wait for a minute for this to resolve. Okay, while it is resolving, so far we answered the first question, which is like how to set up the test conditions. Now the second question, like which is probably the most important, is like how to determine which is the best split, right? So let's say there are multiple options available. Now how do I determine which is the best option to pick? Okay, so to do that, we are going to see this example. Okay, now imagine that before splitting, I have a data set. Okay, before splitting, I had 10 records or data points of class 0 and 10 records of class 1. Is that clear? And there are 3 possible ways in which I could split. Okay, I could go with the gender, which gives 6 class 0 and 4 class 1 here, and 4 class 0 and 6 class 1 here. Okay, or I could go with the car type. Okay, and you can see that there are 3 options: family, sports, luxury. And family has 1 class 0, 3 class 1, 8 class 0, 0 class 1, and 1 class 0 and 7 class 1, right? And there is also this third feature, which is the customer ID. If I split based on the customer ID, which is there are 20 records, so C1 to C20, then you have, well, it is only 1 record, right? It's one of the 2 options, so it's either 1 or 0. Okay. Now the question is, which of these is the best way to split this data? Yeah.
So is it like for regression when there's a balance between over BC and under BC?
Well, that's a good question. So, of course, we care about generalization. Like, irrespective of whether it is regression or classification, we always care about generalization.
It's accurate state of time so training.
Yes. So the last one, that's a good observation. So the last one is going to have 0 training error, right? But what would be its test error? No, you can predict. You can exactly tell me what is the test error. What? So given a new test data, let's say 21st student record, okay, or customer record. Now, how can you use this split to make a prediction? Yeah? Yeah. So this classifier is going to have random performance for test data, okay, because there is no C21 here, right? So then there is no way to use the tree. So I can just toss a coin and say whether it is class 1 or class 0, right? So in that sense, the third option is really a bad option. Now, what about the first and second options? Okay, there is an answer in chat, but I'll wait for everybody to think an answer. So which one would you prefer? So how many of you prefer the first option? Okay. How many of you prefer the second option? So what about the rest? So do you prefer the third option? Okay. So I think a majority of you prefer the second option, right? Like, so now let's talk about both the options. Like, now if you think about the gender, so it splits the data into 2 parts. Now, if you think about the uncertainty in prediction, like it is roughly 50-50, right? Like, so there is no clear winner here. Also, there is no clear winner here. Like, so in some sense, you have not gained much by this split. Okay. Now let's think about this second split. Now, once you split like this, you see that this is for sure class 0. This is almost class 1. This is also almost class 1, right? Or in other words, you gained something by this split. Like so, like you can be a little bit more confident about your prediction. Now, for example, this one will stop here. This two, there is very small impurity, like there is one extra class. Like you decide to stop because it is majority, or you continue if you want. Okay, is that clear? So the second option is the best option here. Now, so what is the lesson from this example? So the lesson is, if you think about how my reasoning for the second, right? So my reasoning is very simple. It is based on the fact, like, how homogeneous is this split? Like, is it all 0 or all 1, or is it at least close to being all 0 or all 1, right? Like, so if it is not, then probably it's not a good split, okay? So basically, nodes with homogeneous class distribution are preferred. Is that clear? So homogeneous is the key here. And or in other words, we prefer pure, let's call them as pure nodes. Okay, so we are preferring pure nodes, which means we need a measure of node impurity. If I can mathematically define this homogeneous node, then I can pick the split that achieves high score in this, right? Like so. Now here are some examples. Like so, for example, like when you have class 0 and class 1 both 5-5, there's another split which is like this. Okay. Now, of course, we prefer the second split more over the first split, right? So how do I make this preference, like translate this preference into a mathematical equation, right? Like so. Now the first split is non-homogeneous, okay, and it has high degree of impurity, right? It has high degree of impurity. So what do I mean by impurity? Like it is not from one class, like it has a mixed class, okay, so which we are going to call as impurity. On the other hand, the second one is more homogeneous, okay, and it has low degree of impurity. Okay, now there are various ways to measure node impurity. Depending on which measure you are using, you're going to use different versions of decision tree algorithm. Okay, so however, they are all similar. So we are going to see 3 measures of impurity today. Node impurity, okay, which are Gini index, entropy, and misclassification error. Okay, now irrespective of what metric you are using or measure you are using, this is the general recipe. Okay, so the general recipe is, before splitting you had some number of class 0, some number of class 1, right? You compute the measure, let's call it P. Okay, now we are going to consider these 2 possible splittings. Now each splitting gives you 2 splits of the data set, right? These splits are going to have their own number of class 0s and class 1, right? Now for this particular data set, I can actually compute the measure again, for this again, right? M21, M22, right? So now we are going to combine M11 and M12. So this is the combined measure for this particular split. Similarly, this is the combined measure for the second split. So we will pick the split which gives us maximum gain. Okay, so the gain is defined as P minus M1 versus P minus M2. So you pick the split which gives you maximum gain, or in other words, you pick the split which makes the node more and more homogeneous. Is it clear? Now, for example, let's say M1 is more homogeneous than M2. Then P minus M1 is going to be higher than P minus M2. So you will pick M1. Is that clear? So this is a general recipe, but we are going to see some examples on how to do this after the break. So we will take, yeah?
Can you just please repeat what the P stands for?
Okay, so so this is a very abstract figure. So the P's and M1, M2, M12, all these things are measures like so. We are going to define a measure. It could be entropy or it could be Gini index. Once you have the measure, then you have the formula to compute the measure. So if you compute the measure for before splitting, that is called P. If you compute it after splitting for this data set, it is called M11. Like it is just a variable name. So like we are going to see the formulas after the break. Okay, so we'll stop here and continue at 1:45.